They can be specific questions from homework assignments. They could be general, like, hey, I don't understand like this whole idea. You just kind of tell me where we'll go, and we'll kind of give you what you're asking for, or look at what you want to look at, or talk about what we want to talk about, and we can kind of build from there. Okay? So we'll start there. Victoria? 9 from what? Okay. From the book problems? Sure. So 9 says, identify the vertical and horizontal shift for the function, and then graph on this interval from -4 pi to +4 pi. Well, I remember that the vertical shift and horizontal shift are related to the h and k, and should be pretty easy just by looking at the equation to identify the h as pi/2 and the k as 1. So that basically we're going right pi/2 units, and we're going up 1 unit. Does that feel okay, Victoria? Well, we have to graph it still too, but that's the shift. The vertical and horizontal shift is just from the h and k. And I didn't write down what I just said, but you'd write that down. So to graph something, I'm going to first start by writing my transformation map. And then I'd go to my notes and retrieve the key points for sine, since this is a sine function. Now I have these things memorized. That's not an expectation for you to have these things memorized. This would be information that I would provide you on a test or a quiz or whatever. Now, in this specific instance, my c is 1 and my a is 1. So really what I have is x plus pi/2 and then y plus 1. So I'm going to plug in my x and y and just kind of evaluate things. Okay with that? Victoria, we're still going okay? And I'll just continue to do that for all these 5 points that I've listed, or the other 4 points, I guess. There's that. And then I will draw my graph. So here it asks to go from -4 pi to +4 pi. Okay. So I notice on the points that I have here, the x coordinates are going by 1/2 pi. So that's how I'm going to make my tick marks. So I'm going to have 8 tick marks on each side. Each one of them is 1/2 pi. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we just have to go up 2 units. And then I will plot my points. So pi/2, 1, and pi, 2, 3 pi over 2, 1, 2 pi, 0, and then 5 pi over 2, 1. Oops. And then I'm going to extend this now to fill in the rest of the space. So by extend this, I mean I'm just going to follow the same pattern. So basically this is just going to repeat itself. So I'm going to have, next comes a high point, then a middle point, and then a low point. And then previous to this, there must have been a low point, a middle point, high point, middle point, low point, middle point, high point, middle point, low point. And that would be the graph. Victoria, are you okay with what I did there? Okay. Are there other people that want to follow up on this one? Emilio?
I don't know if you've got the coordinates underneath X and Y. Is that from the table that we did the other day?
So that would have been from our notes. So yeah, right here. So whenever we're graphing sine, we're using those 5 points as our starting points. And then whenever we're graphing cosine, we're using like these 5 points.
Is this something we would have, or do you have to memorize?
That would be something that would be given to you. You do not need to memorize these. Does that feel okay?
Yeah.
Okay. Who's next? Landon?
You do it well.
From the same page?
Yeah.
Okay. So same idea. I'm going to just start by identifying my values for A, C, H, and K. Probably do that. So I would start here by noticing that I would need to factor the inside part there because the leading coefficient on my x is not 1. So I'm going to factor the 2 off. When I factor the 2, basically I have to divide it from each piece, right? 2x divided by 2 becomes x. And then I have pi over 4 divided by 2. That's the same thing as pi over 4 times a half, which is the way I'm going to think about it, which makes pi over 8. So far, so good?
Yeah.
Okay. So my A is -3, my C is 1/2, my H is negative pi over 8, and my K is -1. So far, so good? Okay. So next thing I'm going to do is I'm going to write my transformation map. So I'm going to have CX plus H, and then AY plus K. So that's the same transformation map formula that I wrote down up here, right?
Yeah. Are we expected to memorize that?
That would be a good one to have memorized. We use it in kind of a couple of different ways throughout this chapter. So that would be something good to commit. Is that okay? So far, so good? Okay. So then I'm going to go back and retrieve my key points for cosine that I have listed right here. These you would not need to memorize. Those I would give you. So I'm just going to copy those down real quick. Again, I have these things memorized, but again, math teacher for like, I don't know, feels like a million years now. Oh my goodness. It's 0, 1. Try again, Dummy McDummerson. Now all these are jacked up here. Sorry. Let's try not to make more mistakes than we need to, right? Jeepers creepers. Okay. Totally have them memorized. I wouldn't make a mistake doing that. All right. And now from here, all I'm going to be doing is plugging in my x's and y's into the little formula that I've made and evaluating. So 0 times a half minus pi over 8 is just negative pi over 8. Negative 3 times 1 minus 1 is negative 4. And I'm just going to kind of continue doing that. Is that okay if I just do this part in my head here?
Yeah.
You're okay with the arithmetics?
Yeah.
Okay. I mean, if we need to, we can always write things out, but I don't think we probably really do. I mean, sometimes the fractions are like a pain in the tuchus or whatever, but it's usually not the end of the world. And again, you can always do those fraction operations on your calculator if you just leave the pi out.
Yeah.
You can always use the mathfrak command and then just write the pi back in at the end on your paper or whatever. Right, we talked about doing that before. Okay. So now that I've done this, I'm ready to draw like an XY axis and make some tick marks and draw my graph here. Well, that's a weird spot that I decided to put that. This one, the directions ask to go from from negative 2 pi to positive 2 pi. And if I look at my graph, I'm really going by eighths. So I should have like 16 tick marks on each side. That feels like a lot to me. I'm only going to write 8, and we'll just put them in between. You guys okay with that? I don't think I can realistically keep track of kind of how far I am. And then we have to go down 4. 1, 2, 3, 4. Okay. So just keep in mind, none of these points are going to line up with the tick mark. They're all going to be kind of in between because the tick marks are quarters. And all of my coordinates here are eighths. So let's see, I start down here, negative pi over 8, negative 4. Then we have positive pi over 8, and then negative 1. And then 3 pi over 8, and we have to go up 2. And then 2. And then 5 pi over 8 and negative 1. Come on now. And then 7 pi over 8 and negative 4. So there's like one period. And from here, I'm just going to be extending now. So I'm going to extend to the right. So I'm going to go back to a middle point, and then a high point, back to the middle, and then a low point, and then the same thing here. So on this side, we'll be going back to the middle point, and then a high point, middle, low, middle, high, middle. So there's my graph. Looks something like that. Does that feel okay, Landon?
Yes.
So again, probably the most difficult piece of this is realistically just getting your values for A, C, H, and K and making sure you have the correct ones. Because if those are kind of goofed up, everything after that kind of gets goofed up. But once we have those values, you're just plugging them into a formula. taking these points, plugging those through the formula, graph your 5 points and draw your 1 period, and then just extend each side by continuing to follow the pattern in both directions in terms of how the points go and how the spacing is between them. But really, realistically, I'm just kind of using my eyes to do that. I'm not doing any more calculation. Right? I'm just kind of looking at the graph and spacing them in the same kind of pattern or the same order and the same distances that I did for the first 5. Jane. Sure. So 13 says construct a sinusoid with the given amplitude period that passes through that given point. Okay. So when we say a sinusoid, we mean that we're talking about either an equation of sine or an equation of cosine. It doesn't matter which one you choose. There's always a correct answer for each version. And in fact, there's infinitely many correct answers for each version. Now, in a problem like this, where the type of point that we're given isn't specified, it doesn't say that this point has to be a maximum or a minimum or a midline point or something, I would say that the easiest version to use is to write a sine equation, which is what I'm going to do here. So far, so good? Okay. So the first thing I'm going to consider now that I've chosen to write a sine equation is I'm going to use the amplitude, because I know the amplitude gives me the absolute value of A. So in our case, that absolute value of A is 3. Now, I don't know yet whether that value for A is going to be positive 3 or negative 3. We'll decide that in a few moments. The next thing is I'm going to use my period, because I know the period is equal to 2 pi times the absolute value of C. So in this case, the period here is 2 pi. So I can solve this equation now for C by dividing both sides by 2 pi. So I get that the absolute value of C is 1. Okay with that, Jane? Now, I don't know yet whether the value for C should be positive 1 or negative 1, but I'm going to make that decision right now. So there are correct answers where the C is both positive or negative. In my experience, it never makes the problem any easier if you make the C to be negative. So I'm just going to choose to find one of the answers where the C is going to be positive. I would do this every single time for all values of C, is just choose to make them positive. But for the record, there are answers where the correct answers where the C is negative, but in my experience, they're sometimes more difficult to obtain. And I just, if nobody's specifying that the C has to be one sign or another, I'm just going to always pick it to be that. So far, so good? Okay. Now, to find the H and K from this, what I'm going to do is I'm going to pick a point from the parent function of sine that is going to transform into the point that they specified here, 0, 2. Okay with that plan? So since we're doing a sine equation, I'm going to pick a point from the parent function of sine. The point that I would want to pick is the point 0, 0. I'll explain why in a moment, why that's a good one to pick. If we go back and we look at the graph of sine, so 0, 0 is a midline point. So I'm going to make that abbreviation before it. And there's actually 2 different kinds of midline points in a sine graph. The midline point 0, 0 has a minimum to the left of it and a maximum to the right of it. and say, like, if we looked at this midline point, there the maximum is on the left and the minimum is on the right. So there are two different kinds of midline points. Okay with that? And then in my transform function, I'm going to match that point up with the point 0, 2. I don't know anything about the point 0, 2. It doesn't have to be any specific kind of point on my graph. So what I'm going to do is I'm going to choose that 0, 2 to be the exact same kind of point as 0, 0 is. I want it to be that kind of midline point that goes minimum midline point max. Now, I don't have to do this, but it makes life easiest to do it this way. So there are correct answers where you do something different, and that would be okay. But this is the easiest way to do that. And the overall idea here is when we're making this pairing like this, you have to pair a midline point with another midline point, or you have to pair an extreme point, a maximum or minimum, with another extreme point, another max or another min. Okay with that? Landon, I saw your hand here.
Yeah, I'm just not getting where you pull this.
Where I'm pulling what?
Like, how'd you get x is 0,
that came from the problem. So it told me it has to pass through the point 0, 2. So that's the point that I need to pair up 0, 0, 2. Is that okay? Okay. No problem. Okay. So as long as the x-coordinate of the parent function, as long as that point we've chosen is a 0, then I know the x-coordinate from the transform function is going to give me my h. As long as the y-coordinate from my parent function is 0, the y-coordinate from the transformed function is going to give me my k. And because these 2 points are the same kind of point, that tells me that the a is positive. So now we have everything we need to write our equation. We have the values for a, c, h, and k. And again, you could simplify this down, right? 1 over 1 is just 1. X minus 0 is still x. You could simplify that down. I'm sure the answer in the key is simplified, but for the purposes of notes, I'm going to leave it like this so it's super obvious as to how those values for a, c, h, and k give me my equation. Jane, does that feel okay?
Yeah, so if the values for x and y weren't 0, then how would you
Yeah, so let's talk about that. So remember when we're graphing, what we're doing is we're taking a point from the parent function and we're transforming it using this map, right?
Yeah.
So what we're saying is then that c times the x-coordinate from the parent function plus h is going to give me my x-coordinate in the transformed function. And likewise, a times the y-coordinate from the parent function plus k would give me the y-coordinate from the transformed function. So the reason that if the x and y in the parent function are 0, that they just automatically give you the h and k is because we would do something like the following. So we had like 1 times 0 plus h is equal to 0. So if that x-coordinate for the parent function wasn't 0, then you just have another little algebra equation to solve to get the h.
Now that you say that, I remember that.
Yeah, no problem. Again, this is kind of the trickiest thing to set up to remember, but it's still just the same process that we're using for graphing. We're just kind of running it in the reverse direction, right? But this is why we wait and find the h as the very last thing, because we need the c in order to do that, right? We can't start by finding the h. We have to figure out what the c is first. And likewise, we typically wouldn't start by finding the k. because we would potentially need the A value first. So usually I like to find the A and the C before I go looking for the H and the K, unless I have some other way of finding the K first, which sometimes happens. Does that feel okay, Jane?
Yeah. Thank you.
Yeah, no problem. John?
Could you go a little in depth into graphing the pi, like pi over e?
Sure. When you say in depth,
Well, just explaining it again.
like where we're plotting these things?
Yeah.
Okay. So what I did here, this was negative 2 pi at the end, and this was positive 2 pi. So like in the middle is like 1 pi. So this is like pi over 4, 2 pi over 4, 3 pi over 4, etc. So in between each of these is an eighth. So like 1/8 is in between 0 and 1/4. 3/8 is between 2/8 and 4/8. So just like that's all I'm doing is I'm basically just kind of using fractions. Does that feel okay?
That makes sense. Thank you.
Yeah, and again, like you can just make up, like you can put in the tick marks, like okay, everything's a denominator of 8. So between 0 and pi, I need to have like 7 little dashes. So if there's some dashes already built into the grids, like we did on worksheet 3 or whatever, you know, you can always say, okay, well, this is 2 pi, so this is pi. So halfway has to be like a half. So that's like a half, and this is like 1 1/2. In between a half is a quarter, so like a quarter would come in between 0 and the half. You know, you can just like kind of do it, dice it up like that.
Yeah.
Does that make sense?
Thank you.
Sure. And that's what you wanted, right? From going more in depth, is to just kind of talk about how I know where those things are at.
Yeah.
Okay. Emilio?
Well, actually, I want to ask on the previous question.
Sure.
One thing and then I have another one.
Yeah, go ahead.
For y equals say, sine over, what would be your b and what would be your a in that equation?
So this what I've written right here. So the general form for what I'm doing is here. I'm using C's instead of B's, but it's the same it's the same thing. So the coefficient here at the front is my A. So my A is 3. And the C is here. So my C is 1. Is that what you're asking about?
Yeah, and I'm sure you said this like 10 times, but is that something we would have to know or something that we would get into?
So the general form, you should know that.
Okay.
Yeah. I mean, it might be on there also, but this is something realistically we're going to use a lot. Really, all of the problems in this chapter are kind of built around like that general form for a transformation. So it would be good to have that handy. It just in the purpose of like, even if it was given to you, it helps things go faster if you're just sure what that is. You know what I mean?
Yeah, and then my other one is can you do 7 on worksheet 3?
Worksheet 3, number 7? Sure. Of course. Oh, okay. So the way that I'm going to do this is all of this information was in the notes. So if I go back to the 10.4 notes and I go look at my table here, this is my column for sine. So amplitude is 1, midline is y equals 0, period is 2 pi, the frequency is 1 over 2 pi. So I'll just go ahead and fill those in real quick. Okay, so far, Emilio?
Yeah, you just plug or just throw stuff.
Yep, I'm just copying it off of the notes. And then also, next thing I'm going to do, also in the notes, is my key points for sine are right here. It's this stuff. So I'm going to just start by plotting those points, since my graph is sine. So 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0. So I'm going to draw that part. And now I'm going to just extend my graph in both directions to fill up the rest of the space that's provided. So after my midline point, starting over, I go to a maximum, and then go back to the midline, and then to the minimum, and then back to the midline. And in the reverse direction, I guess this would have come from a minimum. And that's it. So there's not much to do here. I'm just kind of redrawing the basic picture. Is that okay?
Yeah.
Okay. Who's next? Jane?
So for a quiz or a test, we have to memorize that chart, like the information in the chart.
So really just those bottom four,
Okay.
like that the amplitude is the absolute value of A, and the period is 2 pi c,
Okay.
and the midline is y equals k.
Yeah.
Like you just need to know that for the general transformation, which is the same for kind of all of them, right? And the good part about that is we need to really have it memorized, because we're going to use that information when we graph, or when we write the equation from a graph, or if we write the equation from a description. We're using all those same little pieces in all those types of problems, right? So that's the nice part, is that yes, I do want to have this memorized or whatever, but I'm using it like all the time, like all these different types of problems. I'm going to use that same information, so it hopefully makes it a little easier to remember because you're handling it so much. Landon?
Could you go back to the question I asked earlier? I think it was on just like the regular questions. Number 11.
Yeah?
I went back and looked at how you got all the X and Y's. Could you explain again how you did that without student mental?
Sure. So let's do the second point, just for an example. So I'm taking my x and plugging in here. So I have 1/2 times pi over 4 minus pi over 8. 1/2 times pi over 2, excuse me. So when I do that, I get pi times 1 is pi, 2 times 2 is 4, minus pi over 8. I'm going to make a common denominator. Hopefully it's clear that that common denominator should be 8. So I'm going to multiply this first fraction by 2 over 2. That's going to give me 2 pi over 8 minus pi over 8. So 2 minus 1 is 1 pi over 8. So there's my x coordinate.
Okay,
And I'm just kind of, I did all that junk in my head because math teacher. But that's all I'm doing, is I'm just plugging it into the formula and then grinding through the fraction arithmetic in my head. Is that okay? Sure, no problem. Again, if I'm taking a step and it's like, you said you just did that in your head, I'm just can you do one of them more on paper? It's totally fine. Totally fine. And hopefully, if you take a look here, if you look at those x coordinates, you'll see a pattern there, right? They're all going up by basically 2/8. You start with -8, then a positive 1/8, then 3/8 and 5/8 and 7/8. After a couple of steps, you can usually get a sense of, like, it's pretty easy to see what the pattern is, and you just fill the rest of them in. I stopped actually plugging anything in after like the second one because you know what's going on.
there's always going to be a pattern.
They're always going to be equally spaced. Yeah. So once you figure out like what that equal increment is, you can just.
So pretty much you should find 2.
Yep. Does that feel okay?
Yeah.
Okay. And again, these practical, like, what do you really, like, okay, technically what are you doing, but like, what is the little, you know, like, what can I do to make this process a little easier for me? Like, those are perfectly reasonable things to talk about. You know, and sometimes I do these things without even thinking, like, I'm doing the shortcut without even thinking about it, and then I forget to mention it, you know, like this kind of thing. But if you don't understand kind of why, you know, like what you're doing fundamentally to start with, it doesn't really matter what the shortcut is. You know what I mean? Who's next? Happy to do some more. If we have more, you might not. Jane.
Number 11 on
Worksheet 3, number 11. Sure. Okay. So the first thing I'm going to want to do is find my values for A, C, H, and K. I notice right away that the leading coefficient on my x isn't 1, so I'd want to start by factoring. So I'd factor a 2 out. And then 2x divided by 2 is just x, and 1/2 divided by 2 is 1/4. And I guess you know, there's really a pi there, but I just said 1/4 because you get it, right? When I'm doing the arithmetic in my head, I'm just forgetting about the pi's and putting them back at the end. Is that okay so far? All right. So my A is -3, my C is 1/2, my H is pi over 4, and my K is 0. So from that, my amplitude is 3, the absolute value of A. My midline is y equals k, so in this case, y equals 0. My period is 2 pi times the absolute value of c, so in this case, that's just pi. And the frequency is the reciprocal of the period, so that's 1/pi. Are we okay with that? Again, I didn't write anything down. I just kind of said them out loud because they were easy things to do in your head once you had the formulas or whatever. And again, the formulas that I'm talking about, you know, are these things that I've circled in, you know, from the table here. Okay. So next thing I'm going to do is I'm going to write my transformation map. So that's Cx plus h. Oops, should write the value for h in there. And then ay plus k. Since k is 0, I'm not going to even bother writing plus 0. Everybody's okay with that, I hope. And then I'm going to copy in my key points for sine. So again, I'm going back to the 11.4 notes for those key points. And then I'm basically just taking my x and plugging it in, and then taking my y and plugging it in. So when I do that, I have pi over 4, 0. And the next one is going to be pi over 8 plus pi over 4, so that's 3/8, and then -3. And then we're going to have pi over, or I'm sorry, 1/2 pi plus 1/4 pi is 3/4 pi. Zero. So notice that's gone up. What's going on? Quarter. Did I do that right? Oh, I'm so dumb. That's 1/4 plus 1/4. That should be 1/2. My great googly moogly. There we go. So that is going to be pi. And that's going to be 5 pi over 4. Holy shamoles. Sorry about the mental math mistake. Jane, still doing okay?
Yep.
Okay. We'll plot these bad mama jammas. If I look here, so this is 0, this is pi, so that's a half, so a quarter is going to be like halfway in between. Bless you. You're welcome. And then there's that one. And then up there. And then back down to there. And then we'll just continue the pattern, right? So minimum, back on the midline, maximum, minimum, and then same thing over here. Extend my graph. And I'm all done. Does that feel okay? Okay. Oh, goodness gracious. Who's next? Landon.
So it's just kind of like, so if we're taking out the quiz,
Sure.
is it, like, are we expected to have the chart memorized, like, with the whole line amplitude and midline period and all that? Is that what we expected to be memorized?
Yeah.
Okay.
Yeah. I mean, that's one of those that you basically have to use that information on almost every problem, you know? And they're simple. It's not like the key points for sine or cosine where they're like, it's easy to mix up which one is which, or like pi over 2, then what goes next, you know, like you have all the fractions in there and stuff. Feels like, you know, like I don't want to make it all memorization, but I want to take away the stuff that's the most tedious to memorize. So it feels like those key points are a pain in the tuchus, would be a pain in the tuchus to memorize. One, because there's 10 of them, and it'd be easy to get confused as to which one is which and which one goes where, and you know what I mean? Anyways. Okay, who's next? Muriel?
Worksheet 3, view 6.
Yeah. What is 6, this thing? Oh, okay. So first thing I would do is we got to find the values for A, C, H, and K. So I would start by noticing that, hey, got a factor in there. So we'll start by taking out a factor of a half. So half x divided by a half is just x. And then 2 divided by a half is the same thing as 2 times 2. Like multiplication by the reciprocal. So there's that. So my A is negative 3/4. My C is 2. Oops. My H is negative 4. And my K is negative 4. Cool with that?
Yeah. Did you write y equals 5 over 4?
That's a 3. Same thing as what it was before, right? So my amplitude then is the absolute value of A. My period is 2 pi times the absolute value of C. My midline is y equals k. And then my frequency is 1 over the period. So there's that piece. And then I think we asked you to describe the transformation also in this problem. So since the C is positive, we have no reflection across the Y. If there's nothing going on, I'm just going to put like a dash or whatever, not bother to write anything. Since the C is greater than 1, or the absolute value of C is greater than 1, this is a horizontal stretch by a factor of 2. Since the A is negative, we have a reflection across the x-axis. And since the absolute value of A is less than 1, we have a vertical shrink. Since the H is negative, we're going left, and then the magnitude of that. So 4 units. And since the K is negative, we're going down. And again, we'll go down the magnitude of the K, so 4 units down also. I think that's what these problems were asking for, was the amplitude, period, etc., and then that. Does that sound right? I guess I could read the direction. Yeah. Okay. So I thought that's what the direction was. Is that cool?
Yeah.
Okay. How did worksheet 5 go? We should have had worked on that. Nobody's asked anything out of that yet. Do you want to do any of these?
Can you do 2 of this one?
Sure. Okay. Yes, of course. No problem. Okay, so if I'm given a graph like this, the first thing I'm going to do is I'm going to look for the midline, because I can just look with my eyes and see that. Remember, the midline kind of divides it into half horizontally or whatever. So if I look, it appears that y equals 1 is the midline. Everybody okay with visually how I picked that out? And I remember that the midline is y equals k. So right away I know that the k value is 1. So far so good. The next thing I'm going to do is look for the amplitude. So I remember the amplitude is the distance from like an extreme point, a max or a min, back to the midline. So the midline was at 1, that maximum is at 3. So the amplitude would have just been 2 units to go from 1 to 3. Also, so far okay? Next thing I'm going to do is look at for the period. So the period, the easiest way to look for it for me is just going from like minimum to minimum or maximum to maximum. So we're starting at 1/2 pi and we're ending at 5/2 pi. So I know that the period then is just 2 pi, right? If I'm going 1/2 pi to 2.5 pi, I went 2 pi units. And I can use that to solve for C, because I know that 2 pi times C is the period. So I can say then that the absolute value of C is 1. And remember, we always pick C to be positive. So far, so good. So the last thing that I want to do is I want to figure out the value for H and the sine for A. So because I'm doing a cosine function, for my parent function, I'm going to choose the point 0, 1, which is a maximum. And now from my transform function, I have a choice because I have two extreme points, right? I can use pi over 2 negative 1, and I can use 3 pi over 2 positive 3. It doesn't matter which one you use. Both of them can give you a correct answer. Both of them could be acceptable to use. You just have to pick one. For the sake of argument, I'm going to pick the first one there just because it's the first one that I found. Okay, so far? So that's pi over 2, negative 1, and that point is a minimum, right? You can tell because it's a low point on the picture. So, because we're going from max to min, that tells me that the A value needs to be negative because they're opposite kinds of points. So now I know that the A is negative 2. And because the x-coordinate for my parent function is 0, I know the x-coordinate for my transform function is just going to be the h. And now I have everything I need. Does that feel okay? So almost everything that I need is just going to come directly from kind of looking at the graph, right? So I'm going to pull the values for like the period and the amplitude and the midline just from the picture. And then I'm going to use those values to figure out the absolute value of A, the value for C, and the value for K. And then the H I'm going to have to do by this kind of a method. And the sine for A also as well from this. Okay. Emilio? Okay. So the only thing that's going to change is this last step. The values for the absolute value of A, for C, and for K are still going to be the same. So the only difference here is the parent function point that I'm going to pick is going to be 0, 0, which is my midline point that always starts min, midline, then max. So from my transform function now, I'm going to pick my midline point, which is pi 1. And that's midline point goes minimum, midline, max. So it's the same kind of midline point. Okay with that? So that tells me that the A value is positive. And because the x-coordinate for my parent function is 0, the x-coordinate for my transform function is my h. And I'm done. Oops. Does that feel okay, Emilio?
Yeah.
So doing one versus both, like there's not much more to do, right? The only thing that's going to be different can be the sine of A and the value for H. Everything else is going to be the same though, whether we did a sine or a cosine one. Okay? All right. You guys want to clear your desks aside from your calculator and something to write with? You knew this was coming.
I was outlining Tuesday because I was sick, and I was watching a cast video because I was working at home and things due today and tomorrow.
Okay.
So go ahead and try something to start.
You're going on Tuesday? Yeah.
I was on Monday and Tuesday.
Oh.
Yes, same.
Sure, you guys can make it up later if you like. That's fine.
I do.
Put together and figure that out. Okay. So just FYI, there's one question on the front, there's one question on the back. I just didn't want to forget to mention it, as people just do one page of it, because they never knows if there was a back. So just on the first page here or whatever, I put blanks for where I want you to fill stuff in. If there's not enough space there because your writing is big or whatever, don't feel like you have to squeeze it into that spot. You can write it off to the side as long as it's clear what's going on. It's not a big deal if you use blanks or not. I write little, so I always underestimate how much space people need for things. You know what I mean?